So now the next property is flame coloration. This is a characteristic property of the alkali metals. So as you know that they have low ionization energy, right, as you know that they have low ionization energy, so the energy of Bunsen burner is actually sufficient to cause an excitation. You know that why there is flame coloration or why there is color of compounds, the only factor which govern it is the excitation. So as they possess low energy, so even the Bunsen burner flame is sufficient to excite an electrons, and we know that the excitation means that the electron moves from the ground state to the excited state. Suppose electron is present in this state, it moves to the higher state. And we know that higher state is always an unstable state, and it is going to remain there for certain period of time, and definitely it is going to return to its ground state, and when it jumps back to its ground state, it just emits the energy absorbed by it. So that energy which it emits is actually falls in a visible region, due to which there is a flame coloration for the alkali metals. So if somebody is going to ask you about the flame coloration, how are you going to answer? You are going to answer in a such way that as we know that they are bigger in size, their ionization energy is comparatively low. So their ionization energy is so low that even the flame of the Bunsen burner, that means that much energy actually, is capable of causing an excitation, and when an electron gets excited to the high energy state, it remains there for a certain period of time and then ultimately jumps back to its ground state, and when it do so, it just emit the energy absorbed by it, and that energy falls in the range of visible region, that the wavelength of the energy which it emits actually falls in the range of visible region. And that is the reason that the color of the alkali metal, or you can say the flame, is actually colored for the alkali metals. Like for sodium, it is of yellow color, or for let's say this thing, lithium, it is crimson color. So likewise we have different colors for the different alkali metals. Now coming on to the next property, that is the hydration enthalpy. What is hydration enthalpy? It is actually an energy released when a metal is added into a water, right. So you know that on what factor this hydration enthalpy depends. Smaller the size, more it is going to be hydrated, that means more bonding with the water molecules, and more will be the hydration energy, right. And after hydration, that means it will just bound to the water molecules tightly, so that means less will be ionic mobility, means when it forms an ion, it will not be able to move so frequently, right. So on what factors it depends? On the size. Smaller the size, more it is hydrated. More hydrated means more bonding, strong bonding, that means more hydration energy. More hydration energy means that ion is actually you can say that it is bounded in a strong manner, that its ion actually possess the less mobility, right. So in the alkali metals we have seen that lithium is the smallest of all. So that means it will form a strong bond, so it will have high hydration energy, and its ion is going to possess the low ionic mobility. And likewise if we move down, we know that size is increasing. So if I talk of cesium, so it has bigger size as compared to lithium, right. So that means less hydration energy and more ionic mobility, because it is not strongly bound by the water molecules. So this is what is the hydration enthalpy. So whenever you come across this term, you should be clear. See, whenever you take any kind of properties in the periodic classification, you need to just focus on the factor on which it actually depends, and if you can just grasp that factor, your answer is going to be excellent. So because the whole thing just revolve around the basic factor. So here the basic factor for the hydration enthalpy is the size. Size leads to the strong or weak bonding with the water molecules, and likewise we have the hydration energy, and on that it then depends on the ionic mobility depends. So this is how you are going to answer for the hydration enthalpy. So next is melting and boiling point. As you know that they are biggest of all. This group is biggest of all the groups, like out of all 18 groups, it is the biggest one. So that means it is going to have this thing, large size, large atomic size. So that means the bonding is not so strong between them. So that means it is comparatively weak if we compare with the whole periodic table. So that is why they generally have low melting and boiling point. But so that means if we talk about 18 groups, so this group is going to possess the low melting and boiling point because of their bigger size. But as we move down, we know that lithium is the smallest and cesium is the biggest. So that means lithium is somehow comparatively will have higher melting point as compared to the cesium, because here in it the size is small, the particles are closely packed. So obviously the strong bonding is there and melting boiling point is high. But when we move down, that means size is increasing, the bonds are becoming more weak, so that means less melting and boiling point, because low heat is just able to melt or boil them is required. So next property is photoelectric effect. As we have already discussed in the atomic structure that like when we have certain metal probably with low ionization energy and light of suitable frequency falls on that, that light can actually eject electrons from the metal surface. So we know that for an ejection what we need a low ionization energy. So as we know that this group, if out of all 18 groups, this group is biggest of all, so that means lowest ionization energy of all, so that means they can show photoelectric effect, because the ionization energy is too low, electrons are not tightly bounded. But as far as we are concerned with the typical metal which will have the lowest ionization energy, that will be probably cesium, right, because cesium possesses the lowest ionization energy. So it is the best suited metal for photoelectric effect, because it will you can say that when the light of suitable wavelength just frequency you can say falls on it, it can cause the ejection of the electron, and this is what is the photoelectric effect. So that means in photoelectric cell the best used metal is the cesium. Why? Because it is bigger in size, it possesses lowest ionization energy among all alkali metals, so that means ejection of electron is comparatively very easy, right. So that is what is the photoelectric effect.